You know, we live in a world that's powered by these invisible forces, right? But there's this one humble tool that kind of stands out. It's the one thing that translates the unseen, giving us a language to actually understand electricity. So today, we're going to dive into the history of the multimeter, the device that gave numbers to electricity and really helped build the entire modern world.
I mean, think about it. That's the fundamental question that stumped scientists for centuries. They could see electricity, lightning, and they could definitely feel it as a shock, but they couldn't put a number on it. And if you can't measure something, you can't really understand it, and you certainly can't control it. Our whole story really starts with that one single problem.
For a very, very long time, electricity was more of a curiosity than a real science. It was this fascinating phenomenon, almost like a magic trick you could observe in a lab, but it was missing the one thing it needed to be truly useful: the language of measurement.
Back in the 1700s, you had pioneers like Franklin, Galvani, and Volta doing these incredible experiments, but they were basically flying blind. The first big breakthrough didn't come until 1820, when Hans Christian Ørsted discovered that an electric current actually creates a magnetic field. This discovery led directly to the galvanometer, which was really just a needle that would twitch when current was flowing. It was a huge first step, but it could only tell you if there was current, not how much.
And that right there, that was the huge gap in their knowledge. Scientists could see all these amazing effects, but they couldn't answer the most basic engineering questions. How much? How strong? Without those numbers, building any kind of reliable electrical system was literally impossible. It's like trying to bake a cake without having any idea what a cup or a teaspoon is. You just can't do it.
So, suddenly, telegraph lines and electric motors start popping up all over the place, and the need for real numbers, it wasn't a nice-to-have anymore, it was urgent. This practical pressure from a world that was industrializing at a crazy pace led to a major innovation, combining all the necessary tools into one. See, to really understand what was going on in a circuit, an engineer back in the late 1800s had to lug around 3 separate, heavy, and super delicate instruments: a voltmeter for electrical pressure, an ammeter for current flow, and an ohm meter for resistance. It was just clumsy, inefficient, and honestly pretty dangerous.
This simple question was totally revolutionary. I mean, combining these 3 functions wasn't just about convenience. It was about creating a single, universal tool that could diagnose the entire electrical world.
And the solution was the TECH-EVO-meter. The name literally says it all: amperes, volts, and ohms. This was the world's first true multimeter, a single box that could speak the full language of a basic circuit.
Now, what's so cool here is the simple genius behind the design. The TECH-EVO-meter used that same core galvanometer, that twitching needle, for everything. By just switching in different arrangements of resistors and a small battery, it could cleverly trick that one single mechanism into measuring 3 completely different things. It's like having a single camera lens that, with a couple of simple filters, could suddenly work as a telescope, a microscope, and a pair of binoculars. Just brilliant.
Now, the analog multimeter reigned supreme for decades. It taught generations of technicians. But, as electronics got smaller and faster and way more precise, the gentle swing of a needle just wasn't good enough anymore. The world was going digital, and the multimeter had to catch up.
The classic analog meter just had these built-in weaknesses. Its accuracy was pretty limited, and just looking at the needle from a slight angle, that's called parallax error, could give you the wrong reading entirely. The moving parts would wear out, and all those different scales on the dial were so easy to misread. For the coming age of microchips, these flaws were just unacceptable.
And this comparison just perfectly shows the leap forward. The digital multimeter, or DMM, it got rid of the moving needle and put in a numerical display. It swapped out the delicate mechanical galvanometer for a solid-state analog-to-digital converter. This instantly solved the problems of parallax error and mechanical wear. The only trade-off? Well, you needed a battery. But the biggest change? Precision. Oh yeah.
And what a change it was. Accuracy jumped from, say, plus or minus 2% on a good day for an analog meter to plus or minus 0.1% or even better for a basic digital one. This wasn't just a small improvement. This was a 20-fold increase in precision. And that was the key that unlocked our modern digital world. You just can't build things like microprocessors or sensitive medical gear with a tool that's just close enough. You need precision.
So, with this new digital foundation in place, the multimeter started to evolve all over again. It wasn't enough anymore to just measure the big 3, volts, amps, and ohms. As electronics got way more complex, our translator needed to learn some new words.
First, meters got the ability to measure capacitance.
This led technicians quickly test how well a key component, the capacitor, was storing an electrical charge, which is a fundamental part of pretty much every electronic circuit ever.
Next up was frequency. Now, a multimeter could measure not just how much electricity was flowing, but also how fast an AC signal was oscillating, its rhythm. This is absolutely essential for everything from radio communications to the power that's coming out of your wall socket right now.
And this is a really critical evolution, true RMS. See, early meters just assumed all AC electricity was a perfect, clean sine wave. But modern devices create these messy, distorted waves. A normal meter gets this totally wrong. It shows you a misleading number. A true RMS meter, though, does all the complex math to give you the actual effective power, the real work that messy wave can do, and that is vital for accuracy and for safety.
Now, as circuits became more and more powerful, a new priority started to emerge: protecting the user. An accidental slip could connect a meter to thousands of volts, so the multimeter had to evolve from being just a simple tool into a guardian.
Modern multimeters are just packed with intelligent safety features. Fuses prevent catastrophic failures if there's too much current. Overvoltage protection circuits act like an airbag, instantly shutting things down if you connect to a dangerous source. CAT ratings tell you exactly which high-energy environments the meter's safe to use in, while smart features like auto-ranging and polarity detection prevent simple user mistakes from damaging the meter, the circuit, or even you.
So when you think about it, we've gone from a little twitching needle in a lab to this rugged, intelligent device that a technician can hold in their hand. The multimeter has come a long, long way. But its fundamental purpose? That has never changed. And that's really the core of it. A multimeter doesn't create electricity. It doesn't change it. It's an impartial observer. It just connects to this invisible world and simply, honestly, translates what's really happening into a language that we can finally understand.
In a world that runs on this invisible force, the need for that translation is never, ever going to go away. And as long as electricity flows, the multimeter will be right there, silently asking its simple, profound, and absolutely essential question: how much? Thanks so much for joining me for this explainer.